And I'm going to
Recording in progress.
This is the first class in this summer for calculus. Learning calculus is going to testify if you have good enough foundations from algebra 1, algebra 2, geometry, and pre-calculus. Before we learn calculus, I quickly go through the thing in PreCal, okay? Suppose you should already master all those basic functions, graphing, know their domain, know their range, being able to draw the graph by yourself, also including drawing these kind of piecewise functions, okay? Piecewise functions, and being able to tell the asymptote, being able to draw those kind of rational functions and know those asymptote, and also being able to do the long divisions, also synthetic division to tell those slant asymptote, okay? And also we need to be able to solve those inequalities. If you have trouble for any questions in this worksheet, let me know. I have already sent out this worksheet. I will upload this solution today, okay? If there is any specific question, please ask me either in WeChat or send me an email. And I suppose every student in this class mastered the unit circle. Remember all those special angles, sine, cosine, tangent, cotangent, secant, cosecant value, and being able to do the trigonometry inverse function also. Okay. If there is any specific question in this worksheet you had trouble, please let me know. In PreCal, we learned about getting the minimum or maximum values, okay? And we also solve those trigonometry equations. Those questions is not hard if you know that you can do a U sub. You use U to represent cosine X, you will change it to a quadratic equation. You can either do completing a square, factoring, or using the quadratic formula to solve those equations, okay? For this type of question, this can also be changed by a U substitution into a quadratic equation. So if you have trouble for doing those questions, this is the time to catch up before we learn the hard part of calculus. Also, you need to master the logarithm, including the natural log. Okay, knowing all those logarithm properties. Here, this is those optimization questions. In optimization questions, for PreCal, you are allowed to use calculator, graph calculator. For example, this totally plus together give you a 200. And they ask you by what dimension will make this area a maximum. The way we solve it in PreCal is easy because we can just suppose one value to be X. We can call this guy as X. We can call this guy as Y. That means 2X plus 3Y will equals to 200. And the enclosed area will be X times Y. Now, you get this equation. You can solve your Y. Your Y will equals to 200 minus 2X divided by 3. So your area will be expressed by this. Who is this? This is a parabola, or you can say this is a quadratic function. Even without calculator, by completing square, you can get the maximum value. And you can also tell at what X value this function will reach to its maximum. Why this guy go to the maximum? Because negative because this is negative 2x squared. Since the leading term is negative, this guy opening down, it has a maximum, okay? But we will not be just limited to this kind of simple quadratic function to do those optimization questions. Sometimes we have more complicated case. For example, 57. You have a semicircle and you have a rectangle bounded here. You will ask to calculate at what length of x this guy reach to the maximum. How do you do it? It is easy because this y equals to this. And the rectangular area will be just x times y times 2. So 2 times x times y. Now you have the y. You can just make this guy go in here. And to do the area maximum value, you can just plug in this into any kind of graph calculator. So what you do here, you just type in 2x times square root 25 minus x squared. All right. Now this is a real world problem. So you need to ignore the negative part, which you just take care of the positive part. 3.536, when x gives this value, your area y will reach to its maximum of 25. This is algebra 2 and the pre-cal level. If you solve this by calculator, I suppose students in this class already master this skill. What will happen if you were not allowed to use a calculator? What can you do? You have to use calculus. To do in calculus, we want to say this guy is a function of x. If you want to reach to a maximum value of function, you want to do the derivative of that function. So you want to do a derivative of this complicated guys, okay? After you do the derivative, you will get this one. And you want to make your first derivative to reach to 0 to find out your x, okay? So that part of work is a work we are going to learn in this summer class. All right, so this is the work we will learn in this summer without calculator, just doing by hand, being able to do the optimization question. That's a very important topic. If you choose to take those college board AP calculus, either A, B, or BC, you need to master doing this, okay? We still have many other similar questions, like question 58, question 59, okay? When you do this by yourself, I don't force you to do this way because you haven't learned yet, but you need to be able to solve it by calculator. That's the pre-cal level. All right, that's the quick summary of pre-cal about the summer packet. I ask everybody, please finish. I will upload all my solutions today. Make sure you go through all of them. Now let's start calculus. The first thing we learn in calculus is a guy called limit. Okay, it's a guy called limit. Limit. What is the limit? So when you draw, okay, I don't want to make you feel confused by dump a lot of mathematical formulas. You don't need to worry about this part. Let's just draw this graph. With this graph, when you approach, if I want to get the limit at x equals to c, I'm going to approach from the left. I reach to a point. I'm going to approach my function from the right. I reach to the same point. If the limit from the left equals the limit from the right, then the limit exists. That's this value. You say, wow, it's so easy to calculate the limit. Yeah, you just get here, then that point. Oh, I can just go here, say, that's the limit. Wait a moment. This is only easy for those continuous functions. When we come to those discontinuity, we will have trouble to get the limit, okay? So now I'm going to show you how do we calculate the limit. Let's take a look at here. How do I calculate that limit? Does anybody in this class know what's the limit for this value? You can also text me your answer in the chat. Okay, everybody can send me your answer. Go ahead. What's the limit of this one? Go ahead, send me your answer. You can even give me a quick explanations telling me why the limit of that guy is that value. Go ahead. Who knows this limit? How do we calculate this guy's limit? You see, I plug in. When x equals 0, that's 0. When sine x go to 0, that's 0. 0 over 0 is what? You've never ever learned how much 0 over 0 equals. Okay, well, good job, Aiden. Aiden already told us this is 1. Lauren. Okay, Lauren, very good. Yeah, you get the good, correct answer. During the situation, we don't know how do we calculate the limit. There is a basic way just by graphing, okay? We will graph this one. We will type in sine x divided by x. Students, if you are using the TI Inspire calculator, when you do those graphs, you need to make sure that your graph mode is in the readings, not in the degree. Otherwise, the result will not be correct, okay? So this is a graph of sine x over x. The next is 0. This guy give you a value about 1, okay? You see that, it is about 1. But the function itself does not exist at x equals 0. So this function here doesn't exist, but the limits here exist, equals to 1. So this comes back to our original definition. How do we calculate the limits? You always have to approach from the left. You have to approach from the right. If these two values equal, then the limit at this point is that guy. So you write down this guy equals to 1. The real way of calculating the limits is called L'Hospital rule. We haven't learned the L'Hospital rule, but I can quickly introduce a little bit. Okay, L'Hospital rule is a very powerful tool when you want to do the limits. If you have the format of 0 over 0, you will do the derivative of this guy, which go to cosine x. You will do the derivative of that guy, which go to 1. And then this guy becomes 2 cosine x. When x go to 0, this guy is 1. So that guy is 1, okay? But the L'Hospital rule is beyond what we have known right now. So no rush. First, we want to accept that this guy go to 1. Now, all the following question will be based on this. Now, I'm going to test the students' math foundation in this class, all right? Everybody, go ahead. Do number 1, number 2. If you finish, you text me the answers for number 1 write down 1 answer, 2 answer. Go ahead. You are not able to use this one directly, but you will do some manipulations. What do you do? Okay, we get some students find the answers. One student got the correct answer. Who else? Very good. 2 students get the answers. Let me show the trick, okay? Yeah, maybe this is the first time you see this. Olivia, very good, very good. Yeah, we got 3 students got the correct answer. We want to do this way. We copy down this. Sin x over 5x. We are going to write down 1 over 5. Okay, when you do the limit calculation, you can take the 5 away and this guy. Who is this guy? That is 1. So that is 1 over 5. Does this make sense? That equals to 1 over 5. The second one. I will call students to work with me together, okay? Some students have never taken my class before. Some students take my class before. I will start with a student who take my class before, and then we will start with, and then we will go to new students. Aiden, you can unmute yourself. Let's see how do we work out number 2.
Sure, so I multiply top and bottom by 1 plus cosine x.
Okay. Hey, hold on. This guy, if they can cancel, we can let them go.
Oh, okay, that would be easier. Yeah, then you can
Okay,
just change cosine
we
x.
Can, yeah, we
X
can let them go.
0 to 1.
Sure.
So it's just 0.
So
I
this.
did it longer way.
So then 3 times 1 minus cosine x. And cosine x, when x go to 0, cosine x is 1. 1 minus 1 is 0. So this guy will go to 0. Correct?
Yeah, I did it a little longer way. Like I converted it to sine squared and then it was.
Oh, okay.
Oops.
That's fine. It's going to manipulate a lot of trigonometry identity. That's fine. Number 3. Is there any volunteer who want to do this with me together? Any volunteer? No volunteer? Okay. Olivia. Let's do this together, okay?
Okay.
Yeah. No panic, okay? Yeah, you do very well. We can work on it together. That's sine x. This guy is 2x squared. Can we make 1x here and then leave like that? Yes?
Yeah.
So we will do this manipulation, okay? Sine x over x. And then times 1/2. Now who is left, Olivia?
Cosine.
Yeah, we copy down this whole thing here, yes? Who is left in the denominator?
X.
That's it. That's x. Now, x go to 0. This guy go to 1, right?
Yeah.
This guy go to 1/2. This guy go to 0. This guy go to 1 minus 1, 0. So we got stuck here, yes? We got stuck here. But we learned something about triangle summation or double angle formula in PreCal. Yes? Look at this. Sine alpha plus beta equals to sine alpha cosine beta plus cosine alpha sine beta, right? Okay. Now, by manipulate the formula here, that means cosine 2 alpha equals to this. Yes?
Yes.
Cosine 2 alpha equals to cosine square alpha minus sine square alpha. Also equals 1 minus 2 times sine square alpha. Also equals 2 times cosine square alpha minus 1. Students, this is not a pre-calc class. Okay. If you feel like, I already returned everything back to my teacher, then this week, make sure, remember all those things. Okay. I can upload a G sheet. You can print out and you can refresh. Okay. Now we are going to manipulate with those formulas. Look at here, Olivia. Sine square alpha is 1/2 times 1 minus cosine 2 alpha. Yes? And then we can change everybody to the half. So if I do the half angle, sine square alpha over 2 is equals to 1/2 times 1 minus cosine alpha. Is that right?
Yeah.
Very good. So 1 minus cosine alpha is double of sine square alpha over 2. Correct?
Yes.
Very good. Now, this is 1 minus cosine x. We will use this guy, put over here. Oh, sorry. We will use this guy, put over here. Okay? Now let's do it. We already know that this guy is 1, this guy is 1/2. So we can let them go. We can let the first two terms go by just writing down a 1/2. Now limit x go to 0. 1 minus cosine x is 2 times sine square x over 2. Correct?
Yes.
And then this bottom is what? Is x. Correct?
Yes.
All right. Now, let's do something interesting again. I have this guy here, okay? I have this guy here. I'm going to divide it by 2 for this bottom and also for this top. Is this equation still correct?
Yes.
I divided by a same non-zero number. Now, look at this. This becomes to 1/2. Limit x approach to 0. This is sine x over 2 times sine x over 2 over x over 2. Okay? Now, our starting point is here. This guy go to 0, this guy go to 0, so that guy go to 1, correct?
Yes.
This guy go to 1, and then this guy go to 0. So the answer is
0.
yes, that's right. This is 1, this is 0, so this is 0, okay? As long as you don't have a denominator of 0. This is 1, so this guy is taken care. This is 0, so the whole thing is 0. Make sense now?
Yeah.
Very good, very good. Now let me call the next student. Since there's no volunteer, I'm going to call the student, okay? According to the order here. Claire.
Well,
Number 4.
Okay, tangent is sine over cosine, right? So you could cancel sine on the numerator.
Very good.
And then that,
this guy. Go ahead.
so that leaves you with sine x over x, which is just 1.
Very good. This is beautiful. That get canceled. That is 1. Nice job. I like it. Very good. Next one is easy, okay? Sine x over x times sine x. That is 1, that is 0. So this guy is 0, correct? Very good. Let me call the next student. Cindy.
Okay. So for number 6, tangent squared x is sine squared x over cosine squared x, I think. And then, so it's that times 1 over x from like the denominator. And then sine x over x, as we've established, is 1.
Good.
So then we're left with 1 over cosine squared x.
Yeah, hold on. Yeah, this guy is 1. We can let it go, okay? And then this is sine x over x, and then times sine x, right? Correct, Cindy?
Yeah, so it's 0.
Yeah, this guy is 1. Cosine 0 is 1, so this guy is gone. So that becomes sine x, which is sine square x, divided by x. Okay, so this is 1, this is 0. That's 0, correct? All right, next one is a little bit complicated. Let me call student, okay, number 7. Emily. Emily, let's do this together, okay? It's okay, we can do it together, okay? During my class, you don't need to feel embarrassed if you don't know something. We can work out together, all right? As long as you follow me. 1 minus cosine x. There is something we write down just now. Emily, what I want you to do is just read this formula. Go ahead, read this formula, please.
1 minus cosine d, 2, sorry.
Alpha. Cosine alpha.
Oh, alpha equals to 2 sine to the power of 2 alpha over 2.
Okay, yeah. You kind of remember this formula a little bit from PreCal. Okay, now we copy down this formula. Emily, after we copy down this formula, alpha, because Greek people created a trigonometry, that's why they use all the Greek letters in the trigonometry, okay? We can replace alpha by x, okay? So Emily, can you tell me what thing I should put here? We will replace this guy by this guy. Can you go ahead and tell me what I should do?
2 sine to the power of 2 x over 2 squared.
Perfect. That's what I want. Very good. Does this make sense, Emily?
Yes.
Okay. Now, we will write down this at this format. 2 squared is 4. This is sine x over 2 times sine x over 2, correct?
Yes.
And then divided by x. Divided by x. Now, we want to make that guy and that guy appear to be the same. So I will divide by a 2. Divided by a 2. Make sense? Correct?
Yes.
Good. Now, can you tell me who is this guy?
Sine?
We did something like that.
Sine, oh wait, 1.
1. So that guy will becomes to 1. How much is this guy? When x is 0, sine 0 is 0, correct?
Yes.
So 1 times 0 is 0. Do you agree with this answer now?
Yes.
Okay, that's how we do this kind of question. Okay, yeah, thank you. Very good. Next question. Lawrence.
Mm-hmm.
Let's do number 8 together.
Okay.
Who is secant theta?
It should be pi there. If you plug in pi.
Sure. How much is secant pi? Secant is which guy's reciprocal?
Cosine.
Very good. 1 over cosine pi.
Mm-hmm.
How much is cosine pi?
Should be -1.
Very good. Very good. You have good memory of trigonometry values. So this is -1.
Mm-hmm.
Well, in this case, we don't worry about those denominator to be 0. You can plug in directly. So how much?
Since theta is pi, so it'll be pi times -1, so that'll be -pi.
Very good. Perfect answer. Good job, Lawrence. Very good. Next one. Olivia. Let's do number 9.
Okay.
We
So,
can change this. Go ahead.
is it cosine x and then times sine x over cosine?
Yeah, so the top one is cosine x. The bottom one is cotangent is cosine over sine, right? Yeah. Now you tell me this equals to who?
It equals sine x.
Very good. This guy divided by this guy means this guy times the reciprocal of this guy. So it is sine. We write down one more step. That equals
1.
Very good. Nice job. Very good. Now, number 10. Aiden. Let's do number 10.
Okay, so for convenience, I just did I turned tangent into sine x over cosine x, so it's 1 over sine x over cosine x over sine x minus cosine x. And then to make it easier to look at, I multiply top and bottom by cosine x. So it becomes cosine x minus sine x. Sorry, 1 minus cosine x minus sine x over sine x minus cosine x times cosine x.
Very good. After we times this guy becomes 2 cosine x.
Yeah.
The second term becomes 2 sine x.
Right.
And the bottom one is sine x minus cosine x.
So you multiply by -1.
And then times cosine x. And then we will not be able to plug in this because this is 0 over 0. But we can cancel this guy and leave a -1.
Yeah.
Good. So we can make this guy leave a -1. And then how much is this when x equals to pi over 4?
You can turn that into square root of 2 over 2.
Okay. And divided by -1, how much?
It just becomes negative square root of 2.
Negative square root of 2.
Yeah.
All right. Now, this question looks a little bit complicated, but after we manipulate with the trigonometry identity, it is okay. All right. The next two questions is similar. I will leave by yourself. I will show all your notes, all my notes, okay? For each homework, I will upload the blank version and another version with all my notes, in case you forget how to solve by yourself. Now, we want to learn another way to solve the limits. There are several different ways to solve the limits. One way, the first way is called using the graph calculator. The second way is manipulate with all those trigonometry identities and start from something that you have already known. And the third way is called sandwich theorem. Okay, sandwich theorem. You might want to write down this on your notes. It's called sandwich theorem. You were given that guy less than this, okay? And this told you this is true for all the value of x, except x equals to 0. So that means they don't know the x equals 0 or fx value, which means they don't know how much is this, but they want you to get the limits. So you will squeeze from the left by calculating the limits of the lower bound. And you will calculate your limits at the upper bound. The limits at the lower bound, when you make x approach to 0, 0, 4 minus 0, 4, 0, 4 plus 0, 4. Your lower bound is 4. Your upper bound is 4. So your limits has to be exactly of 4. Okay, that's called sandwich theorem. So far, so good?
Teacher,
Yes.
can you pause for like 15 seconds? Just like,
Okay, sure. You want to write down this, okay? If I teach too fast or too slow, too difficult or too easy, you are welcome to text me a message, okay? Give me feedback. I will adjust it, okay?
teacher, I'm good now. Thank you.
Okay. Now, the reason I start with some difficult example is because I don't like the way they teach in public school. They teach you the easiest example. For the quiz, for the test, they give you the hard one that you have never seen before. I like to teach the complicated example in my class, okay, so that we can go through all the hard questions. The recording, I will upload the recording into the YouTube channel. I have my own YouTube channel. Okay, you are welcome to subscribe. Each class I have the video uploaded after the class finish, and I will send out the links. After all the summer class finish, I put all the class video link together so you can have the access. Now, next. We need to calculate this kind of limits, okay? I know this question is a little bit challenge, but I would like to see people's foundation. My foundation means, okay, you are already in calculus. You are supposed to know all these formulas, okay? So students, if you still don't know this formula, this is the time you want to quickly remember and understand and being able to manipulate. To do those following questions correctly, you have to know this formula. If this outside is plus, this guy is plus, then here is minus. This term here is, there is no double, okay? There is no 2 here. When you have here, this is minus, here is plus. Okay, yeah. If this guy is minus, then here is minus, here is plus. That term, always positive. Next. I also have a pre-cal class during the summer. I will also record the pre-cal, upload into my YouTube channel. So if you want to refresh pre-cal foundation, I can also give you the pre-cal link, okay? All right, and that's those basic formulas. And I also suppose all of you know the PreCal triangle. The PreCal triangle is saying this: 1, 1, 1, 2, 1, 1. The pattern is this, okay? This guy plus equals to that. And then this guy. Okay, this is a PreCal triangle. We can give a simple example. This is x plus y to the power of 1. This is x plus y to the power of 2. This is x plus y to the power of 3. This is x plus y to the power of 4. So you might ask me, how do you use this PreCal triangle? Let's do 2 examples, okay? X plus y squared equals, we start from the order of x, okay? We do x squared, and then x, and then x to the power 0, which is 1. We do from the right y squared, and then y, and y to the power 0, which is 1. And then here, that guy, this is those corresponding coefficient. 1, 2, 1, 2, okay? So plus, plus. That's it, okay? If you know the PreCal triangle, you should be able to easily write down this. And let's do one more example. The reason we refresh this knowledge here is because in the next 2 or 3 classes, we will start to learn the introduction of derivative. Being able to do those derivative by the definition, we have to manipulate with those formulas. If we don't know those formulas, we will not able to finish the homework, okay? X plus y to the power 3. 3, 2, 1. 3, 2, 1. Which layer? That guy. 1, 3, 3, 1. You may ask, what happens if it is not x plus y? If it's x minus y, how do I do it? Easy. all the coefficient, all the pattern, still the same. The only thing you do when it is a minus, you will switch between positive and negative. Positive, negative, positive, negative. That's it. Okay, that's it. This is the PreCal triangle. Okay. Yeah, you can try using this, doing to the power 4, to the power 5. Doesn't matter, okay? Since we already finished PreCal, I suppose you also know the binomial formula. Binomial formula is saying x plus y to the power of n. You will do the combinations. Yeah, most time we don't need to master the binomial formula. Binomial formula most time are for those students who prepare for those AMIs or AMC 12. But you know, yeah, one day if you want to take an internship from Google or Amazon, maybe that's one of the interview questions, okay? So I still ask you, know this binomial formula, okay? This is choose 0 out of n. How many ways? One way. Choose 1 out of n. How many ways? N ways. Okay, this is the combinations. All right, this is a binomial formula. I want you to know this formula. For most case, you are able to get it quickly by the PreCal triangle, okay? But for advanced students, you might want to also know the binomial formula. Now, we are going to work on this guy. How do we get this? You see, I plug in. 14 minus 14 is 0. 14 plus 2 is 16. Square root 16 is 4. 4 minus 4 is 0. This is 0 over 0. You cannot do that way. The correct way is called conjugate. Conjugate. We already learned in algebra 2. Conjugate. If you have a plus square root b, then a minus square root b will be called the conjugate. Okay, so let me call student to work on this with me together. Any volunteer? Any volunteer who want to work this with me? No volunteer? This is not hard, okay? This is really not hard. Even if you have a small mistake, I will not yell, I will not say mean words, okay? Don't be scared of me. I'm a nice teacher.
I can volunteer.
Sure, let's do it.
Okay. So you times it by the conjugate, which is root x plus 2 plus 4 on both sides.
Very good.
And that gets you...
Okay, hold on. So I'm going to save my writing by times this guy over here. All right, continue.
So then after you times that, you get on the top is x plus 2 minus 16. and then divided by root x plus 2 plus 4 times x minus 14.
Students, when you do this, make sure you have to copy down this thing all the time until you have the final answer, okay? You cannot let this guy go before the final answer. Good? Finish writing down this. Now, who is the top?
The top is x minus 14.
Very good. Which can be canceled, right?
Yeah.
Very good. You notice that we're always looking for those pieces which can be canceled. Okay. Yeah. Some students, when they got here, they say that's 0 because this got canceled. No, when you have the top and the top bottom canceled, that means this guy is 1. Okay, this guy is not 0. Okay, so that guy equals.
So then you plug in 14, and then that gets 1 over 4 plus 4, which is 1 over 8.
Very good. That's excellent. So this is 14 plug in here. So this is 4. 4 plus 4 is 8. That's it. Beautiful. Okay. Beautiful. This is typical calculus quiz question. Okay. Now next one. Our next one is too easy. We can see here. Yeah, we can take this guy like that, and this is 1 over 7. Okay, we can skip this one. This is too easy. Next one. Everybody go ahead, do this question. Do this by yourself and then text me your answer, okay? Text me your answer. One student gets the answer. Two students get the answer. Aiden, Angela, Olivia got the correct answer already. I noticed that most of you is going to be 11th grade in this coming semester. 11th grade is the most difficult year for all the high school students. So we don't want to get ourselves burned out during your 11th grade. This is the best time to learn calculus. Cindy also got the correct answer. We have 4 students get the correct answer already. We always want to manipulate between those trig identity. Cotangent is cosine over sine, okay? And then Emily, you got correct, very good. Claire got correct, very good. Who else? All right, let's see here. That guy is cosine over sine. When cosine over sine divided by this, then sine will flip to the top. Cosine will cancel. Pi over 2. Sine pi over 2 equals to 1. So this is 2 times 1 equals to 2. Okay. Now, some students get wrong because those trigonometry values. So I will also upload a unit circle. Okay, so this is my class for the summer. Students, if you haven't remembered the unit circle, okay, if you haven't remembered all the unit circle values, I will upload this to the Google Drive. I want you to use a plate paper, okay, a paper plate, and draw those 30 degree, 45 degree, 60 degree, 90 degree, all the way to 330 degree. And then I want you to write down the sine, cosine, tangent, cotangent, all the unit circle value. Okay, make sure this is the best time to do this skill. This is critically important for calculus. Next one. Go ahead, let's do the next one. This one is going to manipulate with the formula which I showed you earlier. I think I draw a formula to you just now. Yes, the question I asked you to do just now, you need that formula, all right? You need that formula. Now go ahead, work on this question. Okay. We get Angela, Olivia, correct answer. Very good. Claire, that's right. Very good. Aiden, correct. One 125 is a 5 cube. So this is x minus 5 times x squared plus 5x plus 5 squared. Yeah, we are doing this pattern again and again. We want to cancel the thing which is 0. And then we can plug in x equals 5 into here so that we can get the answer. So this is the solution. Okay, this is the solution. Next one. Go ahead to this one. Very good, Cindy, Olivia. We have so many smart kids in this class. Angela, that's right. Claire, that's right. We want to do the cross multiplication. Okay, we want to do the cross multiplication. 1 times 1 is 1. -3 times 5 is -15. This guy product meet that. This guy product meet that. And then the cross multiplication summation. 5 minus 3 equals to 2. So this guy is x minus 3 times x plus 5 divided by x minus 3 times x plus 3. So the same trick comes back. Cancel, plug in, answer. Okay. Go ahead to number 6 and number 7. When you give me the answer for number 6 and number 7, please put number 6 answer, number 7 answer. This question we have different students gave different answers. Emily. Emily, let's work on number 6 together. Emily.
Yeah.
Okay. So limit, we copy down this. Sine 6t, we don't know sine 6t over 5t, but we can match a 6t on the denominator, correct? Yes. Here you say this is a 5, this is 6. It is not the same. Doesn't matter. We can do 6 times 5 over 6. Does this match now?
Yeah.
Okay. 6 times 5 over 6 is 5. So this is equal. Who is this? How much is this? This is 1, right?
Yeah.
So that means 1 divided by 5/6.
Is
Which
it
is
6/5?
very good. 6/5. Okay. You divide by a fraction, you will do the reciprocal. Okay. Now, Lawrence,
Yes.
let's do number 7 together.
Okay.
This question, we don't need to overthink. We
Right.
just plug in, okay? Because your denominator is not 0, so we don't need to do those manipulations. We just plug in, okay?
Right.
So 3 times 1 minus 1 over,
1 plus 2.
very good, equals,
It should equal to 2/3.
very good. Okay, very nice. Now, number 8. Number 8. Everybody work on number 8. Don't overthink. If the limit exists, just plug in. That's right, Claire. I want all the students know this, okay? If you haven't learned my class before, you might never heard of this. This is called all students take class. All means sine, cosine, tangent. Okay, here. Sine and cosecant are reciprocal. So you don't need to worry about remember cosecant value. As long as you know sine, you just do a 1/sine, you got your cosecant. You don't need to bother to calculate to remember secant value. As long as you know your cosine value, secant is a reciprocal of cosine. Same thing, you don't need to remember your cotangent value as long as you remember your tangent value. So remember, S to C, C to S, tangent, cotangent, those are 3 reciprocal pairs. All means sine, cosine, tangent are all positive in quadrant 1. S means only sine is positive in quadrant 2. For example, sine 150 degree is positive 1/2 because sine is y divided by the r. R is always positive, it's a radius. Y is positive in quadrant 2. So sine is positive, so that cosecant is also positive in quadrant 2. Tangent is positive in quadrant 3. Cosine is positive in quadrant 4. Who is this guy? 7 pi over 4. 7 pi over 4 is in which quadrant? That guy, -1. -1. Okay? -1. Okay. I have many tricks to help students remember hundreds of trigonometry formulas in a very short way. Okay? But you have to drill those skills. Now, you might learn about and behavior starting from algebra 2. And behavior means, for example, this guy. Without graphing, we should be able, without graphing calculator, we should be able to draw this guy quickly by itself. What does this guy looks like? Who is the asymptote? X equals to 9 is a vertical asymptote. There. Who is the horizontal asymptote? When x approach to infinity, that guy approach to 0. So x-axis is your horizontal asymptote. And then you can draw the graph smoothly and nicely. That's it. Now, they ask you, x approach to 9, x approach to 9. You say, what? Isn't this two the same question? No, it is different. It is asking you 9 minus. What do you mean 9 minus means negative 9? No, this means positive 9 from the left. Listen, this means approach 9 from left. The other one means approach 9 from right. So basically, this guy is asking you, what is your limit value when you approach this point from the left? Let's go to positive infinity. This question is asking you, what's your value, limit value, approach from the right? That is infinity also. Does the infinity exist? No, there is no certain value. The limit does not exist. This is called unbounded. Okay, this is called unbounded. If you ask me, how much is F9? F9 is called does not exist. Does not exist. It's called DNE. Oh, sorry, hold on. For the function value, we should say not defined. Okay, yeah, we should say not defined. Not defined. The limit does not exist. The limit does not exist. The function value called not defined. Yeah, you can write down this. Next one. They ask to calculate the limits value here. Sometimes we can just cancel the by a factor, okay? So this question, here the top is x, the bottom is x times x minus 8. And then we can cancel the x term, and then this is 1, and 0 minus 8 is negative 8. So the value is negative 1 over 8. Okay, so the value is negative 1 over 8. So far, is there any questions? Okay, now we still have many things to teach. Okay, now let me explain. There, they ask you limit fx when x approach to 2 equals to 5. What does this mean? The definition of a limit exists. You have to always mention from your left, remember I already said this doesn't mean -2. This means you approach to 2 from the left. Okay, limit approach from 2 from the left, the function limits equals to 5. And your limits of fx when x approach 2 from the right equals to 5. Limits on the left equals to 5, limits on the right equals to 5, and the limits from the left equals the limits on the right, so that the limits exist. Okay, so that's what this guy implies. You might notice that starting from calculus, learning math is like doing an ELA. You have to write down something like an essay. Okay, that's the annoying part. Okay, now they ask you next, is it possible for this statement to be true and yet f2 equals 3? That is possible. You can do a piecewise function. You can draw a graph like that, which make your limits exist at this value, but the function itself get another different values. Usually, when we draw those parabolas, always say, okay, this is continuous, okay? But starting from calculus, we will start to see a lot of functions which are not continuous, like this. I, on purpose, take out the value here, and I put a new value, make it equals to 3. This function becomes to not continuous at this one point. So this is called not continuous. The limits, yes, it exists. The limits is this 5, but the function at this location equals to 3. Okay, so this function is called discontinuous. This function is called discontinuous. Okay, this is called discontinuous. If this part make you a little bit confused, after the class, make sure look at my YouTube video again and again. Okay, if you continue learning this kind of topic, I will make sure every student truly understand. Okay, what does that guy mean? What does this guy mean? This means your graph on the left of 1, it goes to 3. On the right of 1, it goes to a 7. So this is called jump. You can write down this. This is called a jump discontinuity. This is called jump discontinuity. And then they ask you, does the limit exist when x equals to 1? So you say, the limit exists, you see? From the left, it is 3. But another student say, no, from the right, it equals 7. So what will happen? How do you get that guy? Your left go to 3, your right go to 7. And here, you say, no, the limits does not exist. Okay, the limits does not exist. So now, I want to say something about how can you define a function as continuous. Okay, that might be the most confusing point for many students. How do you define the function to be continuous? Look at this. On this part, the function is continuous. It's because you can draw this graph without lifting up your pen. But if you want to draw here and draw here, you definitely see that I have to lift up my pen. Then this is called discontinuous. So to tell if a function is continuous or not continuous, you just draw it. If you don't need to lift up your pen, then it is continuous. If you have to lift up your pen to draw, then it is discontinuous. That's the most direct definition, okay? Now, so far, I would like to pause a little bit to see students have any questions. Is there any questions so far? No question? Now let's take a look at question 4, okay? This is a given function graph, piecewise function. And they ask you the limits at x equals to 1. So x equals to 1, y equals to 3. Easy, this is easy one. X go to negative 3 minus. 3 minus means approach the value when from the left. So this is 3. You go from the left, the value is 2. This is 2. And then you do 3 plus. That means you approach the value from the right. So here is negative 2. That's why you choose negative 2. So these two are still okay, easy to take care. Next, this is those major questions. Your limits from the left, your limits from the right, both exist, but these two are far away from each other, not equal. The answer here is called DNE, does not exist, DNE. Now let's see F3. Interesting. The function here, you see the solid dots here. There is a value. How much? 1. So you put 1 here. Okay. Next. This guy, negative 2. Negative 2 is here. Approach from the left. Negative, negative from the left. So negative 1. Negative 1. And then you approach negative 2 from the right. Okay, you approach negative 2 from the right. So it is still negative 1. Negative 1. You approach from the left, you approach on the right. And these two values give you the same value. So the limit at this negative 2 is going to equals to this. Okay, you approach from your left, you approach from your right, give you the same answer. So you put here. And the last one here, function value at x equals negative 2. This is open circle. So your function is not defined on here, but this is the position you want to look for. That is negative 3. Negative 3. Okay. Now, let's see here. This graph is similar to this one. The first one, they ask you limit of fx when x approach to 3. Okay. You see here, this guy go to infinity, this guy go to infinity. You can write down positive infinity. You can also write down DNE. Okay. Infinity means the limit does not exist also. Okay. So you have positive infinity because here and here go to positive infinity. Next one, x go to 7. All the way down to the negative infinity. So you write down negative infinity. Okay. Next, negative 4. Negative 4 is here. The function limit go to negative infinity. Negative 9. Approach from the left. Be very careful. Be very careful. Approach negative 9 from the left. Wow, this guy go to positive infinity. If you approach -9 from the right, go to -infinity, okay? And you can tell that's all those vertical asymptote, okay? Now, I will upload the blank version and the version with all my solutions. Some of those questions we haven't covered yet. We will continue learning this from next class. Let me quickly summarize what we have learned, okay? I'm going to mark those questions, those major questions we have been through today, okay? The first thing, we go through the summer packets very quickly, okay? So you want to make sure when I upload this, you make sure you do finish every single questions. I have attached all my solutions there. You make sure you redo it by yourself. And for this worksheet, we spent a long time of drilling the limit calculations, okay? Even though you think now those questions easy, but if you do it from the scratch, from the white paper by yourself, it may still give you some trouble. I suggest you do by yourself from the white worksheet, redo everything by yourself. If you get stuck, check the videos, check my notes until you truly understand being able to do by yourself. Okay, we learned this is a major thing we learned today. You want to manipulate with this. And another thing is called a sandwich theorem. Next one, we called a lot of things about conjugate, okay? Factor, conjugate and factor cancellations, okay? Factor cancellations. That's the same type. And you do want to master all these formulas, okay? And the last thing we learned are those kind of weird piecewise functions. We will revisit this worksheet, okay? So if you, we can hold on this worksheet until next week. The major thing I want you to finish is this summer packets, this worksheet. And for students who need PreCal unit circle foundation, I will attach this to the Google Drive also. Now, I want everybody to confirm your folder, okay? Let me make sure. Everybody, look at your email address. Make sure I get the correct email address. Olivia, Zhao Yuchen, Cindy, Lawrence, Emily, Claire. Did I give access to everyone? Okay. All right. That's for today's class. Make sure finish your homework, try your best, and I'll see you next week. I will upload the video to the YouTube channel and I will send the link. Okay. Bye-bye.
Bye, thank you.
You're welcome.